Thank you very much. Hello, everyone. My name is Yongkuk Jeong, and I'm an assistant professor in production logistics, and I work at KTH Atelier. So first of all, welcome to Atelier. And
my name is Erik Flores García. I'm an assistant professor also in the area of production logistics. Welcome to Atelier.
So today we will talk about the smart production logistics from data to service, and we prepare several cases. What does that mean, the smart production logistics? And we will show you some project that we have done before. And before we go into the topic itself, I just prepare some keyword that we can imagine, start to think about what the smart production logistics is. And I guess you are familiar with these terms, Industry 4.0, IoT, and the CPS, digital twin, and other services as well. And smart production logistics is the top of, or it covers all the concepts here. But when we are thinking about the services itself, it could be the optimization service, it could be the visualization, or it could be the machine learning application, and so on. But here, in this case, I think there are some howlings, but sorry for that. I will try to fix it. Oh, maybe it's from me. Okay, it's better, right? Okay, yeah. So, yeah, to prepare this kind of services, we need to think about, or we need to prepare the service behind. So first of all, we have a digital service layer, and under this layer, we need to think about the interfaces of below this digital services. And there are some other protocols because we might use different devices, different protocols to connect the different devices as well. And under the below of this, we have middleware. We need to have middleware to interpret the different data set or different protocols and so on. And then we could see other database and the connections. And then under this database and the connections, now we see different devices. So the smart production logistics, it starts from the IoT devices and other sensors, and we collect the data. And from this different type of layers, we could transfer the data from our devices through the middleware, and we interpret them into using the interface and using different protocols. And then we could provide the services like the optimization and the monitoring and so on. So we are trying to, in our research group, we don't develop any a robot or the services for the production logistics, but we interpret or we integrate different type of data or different type of sensors, and we try to develop the digital services for the production logistics to the customers. And Erik can explain the more detailed stories.
Yes. Thank you, Jake. So before I start describing what is it that we do in the research group, the question was asked in the last presentation, who develops the services that will be used for 5G networks? We can raise your hand. Yeah.
We need to email him.
Yes, exactly. We need to join his consortium. Yeah. So what is it that we do when it comes to digital services? Well, first of all, we focus on moving. Things that move inside factories. It can be information or it can be materials. And it can be between sites, inside a site, or inside a station. We apply different sensors into this environment that I'm telling, and we pick up data that we can then analyze. What we do with this then is that we try to develop real-time response to how things are occurring in the factories. And while in the past it was very much a priority to achieve economic benefits, what we try to do as a research group is to provide both economic but also sustainability benefits. We do this in a number, or have been doing this in a number of research projects. I think we started very early, like 3 years ago.
18.
Yeah, exactly.
19.
So I think it has gone well. People are interested in the movement of materials and information in factories. So what you can see is, I guess, the flow of information or the data cycle, and how is it that we target this. Both questioning how is it that we pick up, how is it that we analyze data, and how is it that end users get access to the information about factories. These are some of the examples of the projects that we have recently closed down, but also running together with several partners. And I guess our last project is this one, started this month together with companies from Korea and Sweden. What is it that we do? When we talk about digital services, what does that even mean? Our interest is that people can benefit from data that is being picked up in factories. And the reason why we talk about digital services is because I guess both you and I consume a lot of these things in our everyday lives. When we buy coffee, when we transport ourselves, when we buy clothes, when we pay for whatever it is that we're paying, we're consuming digital services with our phones. And I guess one thing that has always intrigued us is, can we not do this inside a factory? Do we need to do this paper and pencil all the time? Is it not possible that we customize services to the needs of people who have a certain process? That's a core concern for us.
Yes. And on the top of that stories, so I would like to show you that how does that mean and how does it look like in our research work. So based on the framework that Erik introduced from the data to the service, we developed a digital twin from our lab. So this is not developed in the industrial case, but in this building, we have a production logistics lab, and I think there is another session tomorrow. We will have some demo session, you will see more. But in this video, it introduced our digital twin. So in our production logistics lab, it's kind of the future scenario of the production logistics. So in this case, we don't have person here. We have the collaborate robot, and we have AGV, and we have the real-time tracking sensors, and we have the quality inspection 3D camera and the 2D camera as well. And those different type of devices are connected to our middleware, and we interpret the data, and we develop the digital service. For example, this digital twin. Okay, so here we try to collect the data from the collaborate robot, so we can collect the coordinates of the part of the collaborate robot, and we interpret them to our digital twin model, and it was here in the below. And at the same time, the location of the AGV is also collected from the real, the physical site, and we interpret them into this digital twin. And in this digital twin, the collaborate robot and AGV, they cannot communicate because it is from the different providers. So what we did is when the collaborate robot finished their work, and we can call our AGV to pick up this picking boxes. And at the same time, when the collaborate robot tried to make this kitting things, and they also can detect the location of the boxes using the 3D camera, which is also from another suppliers. So it is all about the integration part, and based on this integrated information, we try to provide the service that what we can do with this digital twin. And if we go to the next slide, that is, there are two scenarios that we can use this digital twin in production logistics. So, for example, this AGV is quite expensive, and maybe some companies, they can immediately introduce the AGV in their production site. But before that, maybe they need to simulate, and they need to calculate if it is cost beneficially or not. So with our digital twin, let's say I have one AGVs, and I want to try if it makes sense to have like a multiple AGVs in our factories. And then you can virtually add AGVs in our digital twin. And since our digital twin can communicate in the real time with the physical world and the virtual world, so the physical AGV and the virtual AGV, they can work together. So for example, we don't know if this way or this area is enough to have multiple AGVs, and we don't know if we have enough AGVs to deliver the number of the product that we want to deliver. So those kind of simulation, but in real time, collaborate together with the physical and the virtual environment that can be provided with our digital twin. So it is close to the simulation, but we are using the real-time data. And then we can make the decision based on these digital twin services. And now, until now, we are just talking about this like a technological development. And there are some like a report and the researches about the paradigm has been shifted. So not only for the technological development, but also we need to also think about what is the value. Didn't we think about the climate change and the sustainability and more human-centric things? So that until now, Industry 4.0, when the Industry 4.0 was emphasized, we were talking about many things in the technological-oriented things. But now some people start to talk about Industry 5.0, and it is about social, technological, and the environmental friendly. It's more about the value-driven approach. So we also thought about this transformation. So what do we need to do? Are we on the right track, only developing the technological stuff and integrate everything? But maybe also we need to think about the value perspective as well. So a bit more about Industry 5.0. Many people, I don't think it's like a clear definition about Industry 5.0, but I just refer several report and the papers that is close to what we are thinking about. So they are using Industry 4.0 technological stuff, but also the thinking about the value first. And in the European Commission, they emphasize three perspectives for the Industry 5.0. First is the resilient. Other presenters, they also emphasize it. And the sustainability, the circular economy was also emphasized. And also the human-centric perspective is also emphasized. So in this perspective, we also start to think about then the digital service. When we are developing the digital services, how can we emphasize the resilience? How can we improve the sustainability and the resilience? And how can we consider the human first? So we started to shift a bit to consider this value more. And there is another example. Sorry for that. The Industry 5.0, it's so different, similar stories, but also there are some technological layers which was like an enabling technology from the Industry 4.0, maybe even before. So this like a smart CADM or the IoT big data is kind of already established the technologies. But in Industry 5.0, we need more technologies, which is emerging technologies. For example, the cognitive cyber-physical system or the smart materials or smart wearable devices. So not only from the technologies already developed, but we also need to consider the emerging technologies. And then based on that, we could have the smart component layer, so which is the combination of this emerging and the enabling technologies. But not only this technological perspective, but also we need to consider this value layer. So when you are developing something, we need to consider this value. And in this reference that we referred here, they emphasize this economic sustainability and socio-environmental sustainability should be considered when you are developing the services. So yeah, let's go back to our stories. So in our lab, as I mentioned, we have like this small version of the production logistic environment. I don't think we are representing all the production logistic environment, but we can do some experiment here. So when we are developing these services, we are not just developing the service from our side, but we are collecting the data from the customers, from the user perspective, and we try to develop some dashboard and the digital services from the customer's needs. So there are some examples like that. And also, many people, they are thinking about how the human and robot can collaborate together. So we also put ourselves here in the lab. As I mentioned, there is no human here, but we try to think about the future scenarios. What if the human and the robot need to be collaborated in this kind of situation? So maybe, as you saw before, like enabling technologies, IoT solutions can help. So for example, the ultrasonic sensor basically can detect the distance and it can give some alarm to the operator when the moving objects are close to the human operator. So it could be used as a safety perspective. And also, if there is like a significantly maybe dangerous area, we could think about other like IoT sensors, like for example, the laser curtains or other alarm systems. So it is not only about one like a single source that we are using, but there are multiple sensors might be required. For example, the autonomous car, they have like a bunch of sensors in the single system. And also how to communicate between the robot and AGV. So maybe we can use our gestures to call the AGV, and maybe this person wants to, because now we need to go to the control panel and we need to set click the button and we need to send the AGV, and that need to be done by some work. But if we train this kind of gestures, and maybe if we have some kind of sign that we want to use as a signal to the AGV, then maybe we can use. And maybe it's an emergency situation, we can stop all the production line with some kind of gestures. So based from this scenario, we started to develop some prototype as well. So maybe you can also help me to show this. Yes, it's me, and I was trying to do some tests. So it's basically the representation of this. So when I just raise my right arm, and then AGV will start to pick some stuff to there. And if I just raise another hand, then AGV will go to the charging station. It looks very simple, but behind of these digital services, we need to think about, so okay, what kind of data do we need to provide, and what kind of protocol we need to consider to send this data to our AGV and so on. So it looks very simple here, but here we collect the human operator's movement from the camera, and it goes to the system. And the middleware, they send the data to the AGV as well, and the communication is working in real time. And now this service is the rule-based. So for example, how can we distinguish this is the right arm, the left arm, and what is the angle of that? So I have some a range of the angle. But in the future, we are trying to train the model, so maybe we can understand the human operator's behavior in the real production site and use that gestures or the signatures to communicate with the robots. Yeah. And then we will talk about the next step.
Exactly. I guess a concern of ours is the needs of factory workers. And these might be some examples that are at the prototype stage. But something that we wondered a lot, both Jake and I, is that if I think about the people who are working in the factory, there are different genders, different age, different nationalities, different languages, but we all strive in a production logistics context to deliver things in the right time, in a sustainable manner. So I think that is where we are heading. And this requires, as Jake exemplified, a lot of new types of data acquisition that we need to analyze so that we can develop this type of services. So that's where we're heading off next. And I think also I would like to highlight that for us as a research group, this is very important, that trying to provide solutions that are meant for factories that have processes that have been there for a really long time in a cost-effective way, and that we are able to do so as things change in the factory. We are not interested in presenting the best possible solution that nobody can follow. Instead, what we try to do a lot is, what is the problem right now, and how is it that we can react to the problem that is happening as it happens? Yes, so that's who we are. If you would like to know more about what is it that we do and how is it that we do it, you're very welcome to visit our webpage or our YouTube channel, in which we have different examples of what we do and details about the research projects that we have.
Thank you very much.
Thank you very much for a very interesting presentation. I'm curious, actually, we have been having some discussion on the security issues related to, for example, opening up in digital environments, right? And we also have heard about concerns, regarding, for example, moving from this 4G to 5G and all that stuff. And I'm just wondering, for example, what you are doing here is very interesting. How are you addressing those concerns within the factory environment? Of course, I mean, that's your boundary. And with your expertise in this area, how do you see going beyond the factory and, you know, talking about the larger systems and the concerns that 5G implementation solutions are seeing, the sort of resistance they are seeing? Because I personally think that 5G and the technologies related to that have huge potential in the implementation of circularity and circular vision for at the very large scale. But there are serious concerns, right? So I would just like to hear your opinion on that, expert opinion on that. Thank you.
Well, as far as cybersecurity, I guess we haven't walked into that field yet. And I totally agree with you that it presents a lot of vulnerabilities to load up and replicate the factory into a virtual environment. Unfortunately, as I said, this is beyond the work that we have done right now. Would you like to?
Yeah, maybe I want to emphasize, maybe when we are storing data, we need to be more careful what kind of data are we storing. But I think, let's say we are, like in my case, my face was rebuilt in the video clip, but maybe the operators, they don't want to. So in that case, maybe the solution is, even though we are collecting like a video image, but we don't save all the images. Maybe we are just saving the coordinate information, and maybe we don't need to connect those information to the personal information, or even we don't need to connect them to not the personal information, but we can save like a team's like a performance. So maybe there are other ways to store the data. So when we are collecting the data, we need to think more about is it really like a right way to save the data? Do we really need to do this? And what is the operator's like opinion about that? So I think before we go into like a cybersecurity, but when we save the data, we need to consider that one first. Yeah.
As far as 5G, I think we're bounded by what is it that we research about, and our focus is the factories. But I guess we could provide some sort of input into a supply chain perspective.
From your expertise here, that even the factory environment actually could be, you know, from the safety point of view, for example. So there are vulnerabilities, right?
Yeah, absolutely.
And maybe if you could reflect on that. I mean, if in your developments, what sort of, let's say, measures you take exploiting these technologies, which actually make sure that, you know, the things remain safe for use. And that is something that we can, you know, learn from and take outside the factory as well.
Maybe we had one project together with Ericsson and Scania, and Ericsson installed the 5G private network to the Scania to test the real-time location sensors. So I think the private network we have tried, but as Erik mentions, we were like using the technologies, but we didn't really reflect on is there any possibilities to like bring this case to the bigger society. But that was our case in this. Yeah.
Well, thank you for a very interesting presentation. I think it's impressive what you've done with the interoperability of the different systems to deliver what you have done in your experiments. But I would like to ask how far away or what more efforts are required for it to move to a more digitally mature solution where maybe the logistics system can be autonomous and the system itself knows where to get what material to provide where and can also execute this autonomously without or with only human supervision?
In my perspective, it really differs based on the industry, what we are talking about. Because, for example, when we are working together with autonomous industry and when we are working together with the steel manufacturing company, the situation was totally different. So I guess the autonomous industry who produced the personal vehicles, maybe they are more like a mature enough, and maybe they have more data, more service to use. But in our case, especially in our case, we try to find a case with the lower mature level so that we can provide service and we can have a better impact. So in our case, we was not intentionally looking for the case from the lower maturity level cases, but we ended up in those cases to maybe we can provide a better impact based on the digital services. So in the maturity levels, I think I can say we work on very lower maturity level. And maybe you can add something.
But how much effort would it be to reach a higher maturity level?
I'm sorry?
But how much more effort would it be to reach a higher maturity level in terms of more autonomous logistics systems?
I think the answer would be it depends. It depends on what area of a factory we're talking about and what type of a product. In some cases, I think it's reachable, very reachable. I mean, we have tested it in our lab. It works. I think that there are areas of certain factories that look like our lab. Other areas do not look like that at all because of processes or how old the system is, etc. No? So I think the answer is it depends.
Thank you very much.